So what I got going here is a basic 2-transistor current regulator circuit, R1, Q1 at the top, and then further to the bottom half, Q2, R2. So I've chosen R1 being about 1500 ohms, Q1, Q2 are the same transistors. I have to check what the part number on it is. I removed it from a color TV circuit board. And R2, I have 2 resistors in parallel to make up approximately 62 ohms, 50 to 62 ohms. Low value resistor is supposed to be R2. So I've just done a basic calculation here. I guess I used 24 ohms in the calculation, but it comes out to more or less the same, I guess. A little less current should be evident, which is in fact the case. Right now my battery voltage is running at, it should be running at about 12.5 volts, which I will try and measure here. 12.41 volts, and with this circuit in operation, I am reading the 250 scale, as you can just perhaps make out. No, it's pretty blurry, but on the 250 scale it's just past, so maybe at about 20. So dividing the 250 scale by 10 is the proper reading of this would be about 27, maybe 28 milliamps coming in through the load. I guess I should specify the load would be the variable resistor, and the ammeter providing essentially zero resistance, just reading the current flow through the entire circuit, would be in line just after the load or just before the load. I suppose it would make no difference. But at the travel of the variable resistor fuel gauge here, or fuel float, is at its max point, which is about 250 ohms. I'm reading about 28 milliamps. So if I rotate this to about the 40 ohm position, we can see that our current drops off slightly to about 23.5, 24. So depending on how I vary... Oh, it bounced for a moment there, I'm not sure why. But I'm varying it, and it's changing between 27 to about 23.5 milliamps. I guess that's a fairly constant current. I've also taken the liberty of hooking up a voltmeter parallel to the ammeter, or load, as you've seen in the diagram, and my voltage will be varying at 250 ohm position of the potentiometer is 1.14 volts, and at the 40 ohm position of the potentiometer is 6.04 volts. So if I move back to the 240 or 250 ohm position, it's 1.14, 27.5, 28 milliamps, and I'm just feeling this portion here with my thumb. I'm feeling no temperature increase through this fuel float switch. So from this prototyped experiment, I'm logically concluding that 28 milliamps through a fuel float switch would pose no danger within a fuel tank. So I guess this circuit will effectively limit the current. Why it's not keeping it 100% constant, I guess I'm not entirely sure. Perhaps it's a limitation of the circuit itself. So I guess the issues now that are when the battery is close to dead, say 10 volts, to when the alternator of the car kicks in just after starting, could be as high as 13.5, 14 volts. So that is it's a huge variance that I would like to try and eliminate on the input side of the positive point. See, I've crossed out 10 volts and put 12.6. Right now I'm at about 12.5. So that would pose a potential problem with maintaining a specific window or voltage range with this circuit that I can basically feed into an op amp before putting into my fuel gauge. So I'm guessing I'm going to have to use a voltage regulator, perhaps an LM317 or a KA317, which I've removed from a color TV, maybe to keep that at the crossed out 10 volts instead. I guess this video is all over the place at the moment. I'm hoping as I proceed further on this project it'll start to make more sense to any potential viewers. For now, hopefully it made some sense. Thanks for watching.